Alright, hello everybody, we're in section 3.3 and we're going to look at properties of a function. So here what we're going to do is we're going to take this graph, so I have a graph here and I'm switching to our function notations. Here I'm using f of x instead of y. So here I have some function of x with respect to x. So let's take a look at some questions. Okay, first I want to find the intercepts. Remember, intercepts are where you hit the x or y axis. So here it looks to me like we have three of them. Here's an intercept, here's one, and here's one. So our intercepts are the points minus 1, comma 0, 1, comma 0, and finally 0, comma 2. Those would be our three intercepts. Here are x-intercepts and here is our y-intercept. Okay, next up. Okay, now we want to find the domain of the function. Remember, the domain is all the inputs, all the x values. So when you're looking for domain, what you want to do is you want to look left to right. You want to look at the x-axis, so you're talking about x values. So I look, and first of all, this function doesn't have arrows, so it doesn't go off to infinity. I look and see when does it start having x values. It's right here at minus 3. Coordinate at this point is minus 3, comma 3. So I start having x values at minus 3, and I close it because this is a closed circle. I closed our brackets. Then I have the function, I'm looking left to right, and I stop having the function over here at 3. That is the domain of this function. Minus 3 to 3. Those are the acceptable inputs. That's where the graph exists. Those are the axes. Okay, let's take a look at the range. Okay, range, that's your y values or your function values. So domain, you look left to right. With range, you look down to up. So I look and say, okay, I don't have anything down here. There's something down here. I start having the graph here at f of x equals 0. Remember, I'm looking at this y-axis. So I get 0, and it's closed because this is a closed-in circle. And I stop, I have all of these y values up until I get to the 3. That's the range, from 0 included up to 3. So I don't have anything up here and I don't have anything down there. Okay, next up. Okay, part 4. We want to find the intervals for f of x, increasing, decreasing, or constant. So here, where is your key word? You're talking about x values here. You're saying where the function is increasing, decreasing, or constant. So let's deal with increasing first. So as I look at this graph, you can kind of like trace along here first. Here the function's decreasing, here it's increasing, here it's decreasing, and here it's increasing. So the function is never constant. So let's start with the first part. Where are we increasing? So f of x is increasing over here, and we're talking x values. Remember, increasing, decreasing, and constant are always open intervals. Always open intervals. So let's see. F is increasing. Well, this is the first slice here where it's increasing. So here the graph goes up. So here, and we're talking about x values. So it starts at minus 1, comma, up until here you have to do x values. So it's until x equals 0, union, and then it's increasing over here from 1 to 3. Open intervals, and you're looking at x values. So as x goes from minus 1 to 0, the graph goes up. As x goes from 1 to 3, the graph goes up. So here the graph is decreasing over, well, that would be from minus 3, that x value, again, open interval. Here it's decreasing up until minus 1. Union, here it's decreasing as well from 0 to 1. Decreasing from minus 3 to 1, decreasing from 0 to 1. And it is never constant. Okay, next part. Okay, last question for this graph. Is the function even, odd, or neither? Remember, this is one of them. It's either even, odd, or it's neither. It can't be a combination of even and odd. And when you're given a graph, the way you want to look at it is you want to see what the symmetry is. So even functions are symmetric to the y-axis. Remember, that's f of x. We're treating this as the y-axis, same thing. And odd functions are symmetric to the origin. So let's see, where's the symmetry with this graph? If it's not symmetric at all, the answer would be neither. But here it looks to me like this graph is exactly symmetric about this function, the y-axis, therefore this guy is even. Okay, and that's looking at a function's graph and getting a bunch of details from it.